You know, something really strange happened recently. For decades, software was basically just a calculator, right? It took our inputs, ran through some hard-coded rules, and spit out an answer. But look at the digital world today. The machines stopped just calculating.
Right. They actually started helping. They began retrieving information, remembering our context, planning out actions, assisting us in ways that feel, well, surprisingly human. But that naturally begs the question, doesn't it? How exactly did software evolve into something that could actually answer and act? That's the exact journey we're exploring today. Welcome to this explainer. We're going to break down the foundational realities of modern AI, specifically deep learning, embeddings, and agentic systems. And we're doing it completely without the hype, without the intimidation, and strictly from first principles. Let's just dive right in. Section 1, Beyond Simple Prediction. We really have to start with a reality check here. For a very long time, machine learning was entirely about prediction. But prediction alone always feels a little incomplete, doesn't it? Because true intelligence requires context. Just spitting out an isolated answer isn't enough. The system has to understand the actual world that those answers live in. Exactly. Because reality is just messy. Think about a retail sales prediction or a business dashboard tracking customer behaviors. Those things don't move in perfectly straight lines. People improvise, markets suddenly shift, a new promotion changes everything. So for a machine to be truly helpful, it first has to figure out how to structure all that messiness, right? Spot on. And that brings us straight to our first fundamental concept, representation. Before these models can even begin to learn, they absolutely need structure. Representation is literally just turning reality, like that messy business problem you mentioned, into a usable, calculable form. It's the hidden shape beneath all artificial intelligence. Kind of like reading a map or plotting coordinates. It's quite simply how the machine sees our world. Section 2. The engine of learning. Okay, so once the machine actually has this map, how does it learn to navigate it? I mean, when we watch how incredibly fast AI is advancing right now, it is so easy to assume there's some sort of magic happening inside that black box. How is it learning without magic? Well, it's never magic. It is really just thousands or even millions of very small, layered adjustments. Information goes in, it passes through these layers of tiny mathematical calculators, and every single layer extracts something slightly more meaningful. It starts with simple edges, moves to shapes, and eventually builds up to complex concepts. So it's kind of like a kid learning how to ride a bike, right? They aren't sitting there mathematically calculating gravity. They just wobble, they fall over, they make a tiny, almost invisible adjustment to their balance, and then they try again until it finally clicks.
That is literally the perfect analogy. And that's exactly what a neural network is, a layered system that just constantly improves through adjustment.
Learning happens when mistakes travel backward. Wow, okay. That actually fundamentally changes how I view this. So the machine makes a guess, compares it to reality, and the error itself, the actual mistake, is the guide. It tells the whole system exactly how to adjust its parameters for the very next attempt. You hit the nail on the head. Intelligence really only grows when feedback becomes useful. Without an error, there's no correction. That mistake literally travels backward through all those layers we just talked about, slightly tweaking the rules as it goes. And through millions of those repetitions, the network gradually molds itself into a system that's capable of some truly incredible accuracy. Section 3. Mapping meaning in space. Okay, I totally get how it adjusts now, but numbers and math are one thing. What about language? Human language feels so messy and abstract to us. How do our words actually get translated into these adjustable mathematical layers? That is the big question. For machines, language absolutely has to become structure first. We can't just feed the word apple directly into an equation. So entire sentences are broken down into structural pieces called tokens. A token is basically just a piece of language, maybe a whole word, maybe just part of a word, that the model can actually process numerically. But here is where the concept gets genuinely beautiful. If we just assigned random numbers to these words, the machine would learn absolutely nothing about what they actually mean. So instead, the system places all these tokens into a massive, multi-dimensional geometric space. And it learns to group them. Words that show up in similar contexts physically move closer together in that space. Meaning itself literally becomes searchable as geography. No way! So similar ideas literally live right next to each other in the math, like king and queen cluster together, cat and dog become neighbors? That's spatial clustering. That's the real secret to the AI actually understanding us.
Yes, an embedding is quite simply meaning represented as distance. And that right there is exactly why an AI can search for broad concepts rather than just matching exact keywords.
Section 4. Context and connection. Wait, hold on a second. A single word can mean totally different things depending on the situation, right? Like, a bank could be a riverbank or the place where I deposit my paycheck. How does the machine know which embedded meaning it's supposed to focus on during, say, a really long conversation?
Well, it uses a brilliant mechanism called attention. Imagine you're standing in a really crowded, noisy room. You don't try to listen to every single conversation happening around you equally, right? You focus your attention on the one voice that actually matters to you in that specific moment. Attention helps the AI system weigh the relationships between all the words, deciding exactly which clues deserve focus so it can resolve that ambiguity. Ah, I see. So instead of just reading word by word and immediately forgetting the beginning of the sentence, it looks at the entire sequence all at once and connects the underlying context.
Precisely. And the underlying architecture that pulls this off so elegantly is called a transformer. A transformer is basically a system dedicated to understanding relationships. It completely replaces the mystery with pure logic, connecting context across the entirety of whatever you've inputted.
Section 5. Fluency is not truth. Okay, this actually brings up a really critical question for me. If a transformer is just connecting mathematical relationships based on distance and attention, why does chatting with something like ChatGPT feel so incredibly human? Because honestly, it feels like it just inherently knows the truth. And that right there is the most dangerous illusion in modern AI. We absolutely have to separate fluency from truth. Fluency is just really, really excellent prediction. The model is simply predicting the most likely next token based on everything it saw in its training data. So it feels like a real conversation. But truth? Actual truth requires hard evidence, grounding, and real-world verification. So what you're saying is, a beautiful, perfectly grammatical, confident answer is entirely useless if it's just hallucinating the facts.
Exactly. Generation always has to be creation guided by evidence. If we let the system just predict words without any factual evidence to back them up, all we get is a very convincing fantasy.
Section 6. Agents grounded in evidence. Then, how do we actually force these systems to be responsible? How do we build an AI that doesn't just guess words, but actually acts on real, verifiable evidence? In other words, how do we build what everyone's calling an AI agent?
We do it by giving it an architecture firmly grounded in retrieval. A true agent doesn't just guess. First, it receives your prompt. Second, it uses tools to go out and retrieve actual, hard evidence, maybe from a secure database, the internet, or a specific document. Third, it verifies that context against reality. And only then, in step 4, does it actually generate the answer. The creation part only happens after the retrieval part.
Answers should not float. They should stand on evidence. That really summarizes this entire journey for me. From basic, simple prediction to representing our messy reality, adjusting those weights through neural networks, mapping meaning with embeddings, and then finally tying it all together with attention. Modern AI still fundamentally needs human truth and structure to anchor it down.
It really does. AI is an undeniably powerful tool for representation and generation, but we can't confuse that with wisdom. It absolutely requires our oversight. So, as we wrap up this explainer, I want to leave you with one final question to think about. Are you ready to govern AI responsibly and actually build with evidence? Or are you just going to trust the fluency?